Hello, May the 4th be with you. I'm still getting over this cold sore. I have a root canal tomorrow. I already drank my coffee, but this is due to science and coffee. You can follow along with our pub link. We are going over the colorectal cancer project. We're at the end of it. We found the other genes and what they seem to show. It was odd that we found a lot of reproductive system genes as well as cellular transport that were stimulated in our top genes, 23 top genes for colorectal cancer, and then knocking out the AURKA gene, which we saw was a gene that promotes cell division, cell replication, which interfered with treatment for colorectal cancer as this gene treatment for colorectal cancer, most cancers, is to prevent cell division so that it can prevent tumors from forming. And AURKA was allowing them to form, which we originally wanted that to be an Epstein-Barr virus association, because also Epstein-Barr virus is something that causes tumors on that network. And we tried looking at some genes. We only saw that the genes that were actually related to lymphoma were the only ones that seemed to be going back to earlier parts of the project, the diffuse large B-cell lymphomas. So now we're going to go ahead and take those genes and we're going to bring back the information from the original data, and we're going to bring in our large database of all pathology top genes that we have so far. And then if we have enough time, we'll look at the Tableau dashboard, and then we'll possibly be adding more to it. I can only go till about 11:15 because I have some frozen chicken thighs in the oven at like 350 degrees, and I don't want them to get burned. So I'll have to stop it around that time. So it's going to be about an hour. We'll see where it takes us. Oh, this cold sore is so annoying. All right. Really got to be careful when you get dental work done. All these people in and out. I know that the x-ray tech was super clean. I saw her. I know they made notes because I complained about the last lady. Last lady tried, some of these people, they try to get mafia type on you like they're all gangsters and shit. Oh, this one's complaining. Like, dude, I don't want a viral infection, okay? I don't want to cause poor health to my body. In fact, that's a lawsuit, okay? You causing me more harm than not. This bitch needs to be clean, dude. I put it on my original Google sheet, Google's review, and I didn't actually call her a bitch, but she's an older matriarch type, so she thinks she's fucking okay. I don't care. I'm a friendly person, but really when it comes down to it, if you're responsible for handling shit that goes in my mouth and I see that I can see dirty fingerprints on it from the last person's oral cavity, I have gotten impetigo before from a child when I went to get the Invisaligns, and they fit you by the dental hygienist. So those people, they wear gloves and that only protects them, but they're spreading shit all over. I will fucking, if I get something, I'm going to fucking spread shit all over their fucking car handles, dude. Every day. Every random fucking day. I don't fucking care. So anyways, yeah, they try to act like a team that's okay with hurting the public individually unless they team up against you. And then they'll have to go ahead and say, hey, you know what? Yeah, this is your fault, so you're going to have to take the responsibility for it. Yeah, there's people like that. And then sometimes there's people that are like, yeah, bitch, you fucked up, dude. You're gone. Like, you know what I mean? In other words, that's what they say. But yeah. So I'm going to go ahead and share my screen. Be careful of who you let put their fucking disgusting gloved hands that you don't know where they came from or what surfaces they touch, because we have to touch a lot of surfaces. And I wash my hands like 10 times when I'm cooking food, okay? I expect the same courtesy from people handling shit that's going like directly in my oral cavity, all herpes family, all hepatitis family, exposure, as well as like regular airborne and Epstein-Barr virus. That is saliva transported. That is also a herpes family. So let's go ahead and get with it. Let's go to I'm going to share the entire screen. All right. Yeah, I don't know. So anyhow, I'm sharing the screen. This is the RPubs thing, the document. We went over everything. We looked earlier in the project to see if there were some genes related to Epstein-Barr, just the PDL1 and the LMP1, latent membrane protein 1. We didn't see an LMP1, which was related to something along the gastrointestinal tract from the nasopharynx and gastric carcinoma. You would think it would go down and be related to the colon cancer. But Epstein-Barr virus does cause clotting and tumors. So maybe there are, because I believe we looked it up, but I mean, let's see. Let's go ahead. That's the document. Let me just paste that into here. Okay. I also shared it in the details. And then we're going to go ahead and go to my file storage. And we're going to the desktop. And we're going to go to the colorectal cancer, 6 samples. And then we're going to go to this, our markdown file. We have the gene summaries added as well. We can upload that. We're going to also be looking at the last database of all pathologies. So I just want to see if we added any Epstein-Barr virus genes, because I believe we did. None of the, okay, we did. LMP1 or LMP2, we looked for them. We only saw the PDL1, which is CD2, PDL2 genes. But why don't we just go ahead and find these real quick? I'm going to go ahead and add these. I would like to know, let's go ahead and run everything. It won't take that long. And our database with the most variables is going to be, why does this one have 42 variables? Oh yeah, that's the gene, that's the matrix. Okay, let's go ahead and get rid of some of these. Environment objects. So we do have the where's the 60? The columns. And okay, it's a 60 observations, this one. Let's look at that one real quick. So the genes are down that row. And we have the counts SC. We didn't add where it came from as far as the fold change. So we'll go back to each one and add a column from where we merged it. So let's go ahead and do that. Let's look at what they are. It is the top ones, right? The top FPKM genes, 28 variables. And then we got the top TPM genes. And then we got the top counts genes. Okay. And there are duplicates in here because a lot of them are also in other data sets. The top fragments per kilomillion, or the transcripts per million, or the counts. So we're going to go ahead and get those genes. So we'll just go back and we're going to add a column to it. We'll filter out each one. This is like part 5 now, right? We're adding them to our pathology database of top genes per study done since the larger global project. These are considered like local projects, I guess. Not really. I mean, if you look at it, these are little projects, little battles, and then the larger one, the larger war, the global scale. That is our overarching project, which is to get all these top genes from. some pathologies that are idiopathic or that have a known vector. So we've used fibromyalgia and multiple sclerosis and Epstein-Barr virus associated virus. So far we have Lyme disease, fibromyalgia, mononucleosis, multiple sclerosis, Hodgkin's, HIV with Hodgkin's, and Epstein-Barr virus in both. Hodgkin's in the elderly with diffuse large B-cell lymphomas. We also have gastric carcinoma and nasopharyngeal carcinoma. So the only ones in there that are not directly related to Epstein-Barr virus associated, and also autism. Autism, I don't believe we were able to add those genes. Did we add those genes? I think we did. Yeah, we did add those genes. Okay. We'll just go ahead and call that up later because we're going to be running a lot of code. So we don't want to go into it. But that database we went over before, that is in this folder. And it's the current pathologies database. It's going to be the latest one, April 19th. We can just open that up right now. Just once. I don't know what's doing that. And when I go into Microsoft, I'm paying them $12.99 a month, and it's not showing I have a computer on there. Ever since I got that other computer that I had to return because it was even slower than this one. All right, so we didn't add the autism genes to this database. I'm not sure why. I guess we could do that too. Ooh, I'm not sure why we didn't do that, but let's go back and look at why we didn't add the autism gene, because it is an associated database, so maybe that's what I thought, I guess. So we do have the autism. It is, oh no, it's not in this folder. It's in the other folder, the higher folder. It is right here. And then let's just open this up real quick and we'll just look at what happened in here. The autism one. So results. Let's go to results. Let's see what results were. Maybe that had something to do with it because it had a difficult time with it. 8 out of 12, 60% accuracy. And then 75% accuracy overall. These are the 2-class models, I believe. And then that one's 82% accuracy. Seems pretty good. This one is 58% accuracy. And that was in the 4-class model right here. So that's pretty normal for random forest. The larger you have, unless they're distinct, highly distinct, it will have a lower accuracy than the 2-class model because it has to predict many more classes. And then, yeah, so we will look at that later. But for now, I think we didn't have any Epstein-Barr viruses in this one, though. Because let's look at if there were any. I believe maybe that's why we didn't add it. The genes aren't in the data. Yeah. So we're going to come back to this one. We add it. Because, all right, so typically we will add it, but it's not an Epstein-Barr virus associated pathology that we know of. We could actually go and just make a list of those genes from CAG to see. Like, let's just go there real quick because you're here and I have that power. All right. So we're going to go there and then Epstein-Barr virus. So there's some genes here, a genome. See, it's herpes virus 4 is Epstein-Barr virus. Virus-induced gene 2, EBI2. Let's see if that's a human gene. genes. Does it say human? Okay, here's some genes. Symbol EBI2 Epstein-Barr virus induced gene 2. So if it's a virus, this might be just the virus genes. Let's see, HSA. Let's go to gene cards. Oh, it is a human gene. Let's see if it's in the alternate. Yes. No. It's got other names attached. We'll up PTR. We'll look up PTR. Oh, this one. Okay, so these are human genes. We should look these genes up real quick before we exclude them. So let's go ahead and let's see one last time if the EBV genes other than PDL1 and PDL2 are in this data to compare. So we're going to look at all the genes that are here. This is going to be our large data. Okay. When we put it in the Tableau dashboard, this is going to be in that folder. We'll get to that. It's already 10:27, so we'll probably not do that today. But we do want to add that. So I just want to do this real quick. Here is a list from KIG of EBV genes that are human. We'll just lower this, and then we'll go ahead and write them in. HSA. Oh, you know what? Okay, yeah, whatever. That's fine. We're just adding in these genes, not a huge list here. Okay, so now we're going to go ahead and we don't need to have that open anymore, or this, or that, or that, or this, or even this one right here. We looked at our pathology database. We know we don't have. There are 386. These are only the top genes. When we go to the Tableau dashboard, there's every database from each project is in that connection. So that you could click on a gene and see within each study where it's at and the fold change and what's relevant, the summary of the study, and then the gene study ID, as well as what that fold change is of, like baseline, or if it's healthy. Baseline being, oh, it's a disease, but then here's the treatment they did to it. And then, okay, so we'll go ahead and bring this back up. We're going to just see where these genes are in this list. Okay. KIG EBV. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 genes. Okay, so we're just going to make a character vector, and we're going to go HSA, and then PTR, EBS, GGO, PON, PBYG, aniline, HMH, SS1N, MCC. All right. And then let's just make some more chunks here. I was reviewing some SQL and Python because I haven't used Python in forever, but I was starting to recall how to use it. I think I could pick that up quite easily now. And then, okay, let's see in our large database with 28 variables, these genes right here. Actually, it's going to be the, let's go ahead and just look at the data one and see where it's at. Although I think, let's just look at data counts. Okay. Counts EBV. Let's see which ones are in this data. Data counts by gene symbol, %N, %name of this character string. And then we'll see if it shows anything. Oh, there's only one gene in it, and it's MCC. And that one has so when they inhibited the AURKA, this gene was inhibited also, and it's an Epstein-Barr virus gene. The other genes aren't in this, so maybe they're in the larger data one. Let's just see. So we'll go there. Should counts the known genes from listed genes. Okay. Okay, let's go to the data. We'll just name it all. Data all EBV. And then we'll see. Data 1. Data 1 by gene symbol. Oh, which? Data 1 by gene symbol. %N. Counts. Oh, in KBV 10. Data on EBV. See if there's any more names. Oh. Well, seems like none of the listed and known genes from K. That's not traditional with EBN. It goes EBN 1 or EBN A1. Okay. All right. I'm just gonna put we're similar. So it's really not important. It's not there, so it doesn't really matter. And it wasn't all of the 10 genes. So use your inference. Okay. We're always using languages that like are not the same. So there we go. Short end. Let's go ahead and start our pathology database. Top 20 gene data sets and add a column and remove the other columns. The fold change for that column. Okay. So we're gonna open up our console back again. If it was closed when we're gonna look at, let's look at the column names of our environment objects. Top FPKM gene. So it is We're going to use the gene symbol, and then we're just going to use, since it's FPKM right here, we just want the FPKM fold change. So we're just going to use that. Okay, and we're going to name this FC FPKM 20, and then we're going to use top FPKM genes, and it's just going to be all of them, all the rows, but only the first column, and then the 26th column. All right, and then we're going to go FC FPKM 20. We're going to create a new column. It's going to be we'll our source data set. We'll just call it data set. We're going to change this anyways. Data set. Okay. FPKM top FPKM. All right, and then we'll go ahead and look at this one. Yeah, 20. Let's go ahead and do the page table. It looks the same in here, but when it prints out in Knitter, it might not look the same. So you just want to make sure you can make it look the nicest it can. All right, now we're going to do the same for the PM20, and that's going to be top TPM genes, and we're just using the first column, and then for this one it's the 27th. The next one will be the 28th, and then TPM20 by data set top TPM. What is top TPM? Okay. And then let's display this. Now we'll do the same for counts. Top counts, genes. First, and this one's the 28th column. Add FC counts 20 by data set. And we're gonna, for the top counts, display it. 20. Okay. Okay, now we're going to combine this because we have that new description from why we're using this gene, and there's multiple genes of some of these genes where it's from. And then this is the fold change in value. Now we will combine these genes into 1D dolphin. All right, top 60. And we'll just leave it at that. And it's going to be R bind, just bind them because they all have the same column names. It's going to be FC FPKM 20, FC TPM 20, and FC counts 20. Page table, top 60. Oh, okay, one of them does not have the same counts of. Oh, yes. Actually, they don't have the same column name. So we're going to name that. We're just going to add a row to each one. Okay. column name FC FPKM20. They're going to get changed anyways. Gene. Oh, make it a vector. Gene FC source. Okay. So we'll just add that. Control C, copy. We're going to run this code. There you go. There's our new columns. Add this line here. All right. And then, what? Okay. It still shows the wrong name though. FC. Oh, yeah, that's right. TPM20. Make sure you change that too. All right. Okay, and then we'll change it here. Counts 20. And then we can now run this and it should work. All right, perfect. See that? 60 rows. You can just go through each one. And then we're going to go ahead now. Now we will open up our pathology database from projects. Worked on for global project. From local, we'll just go to local. Because like the local minimum, like you like have a curve. There's like a local max, global max, local min, the min at the end, global min. Okay. Below the origin. So we'll go ahead and let's open that. So now we have to go back to our folder. It's on our programs, but it's going to be the our programs folder, all pathologies, current pathologies. We are going to copy this address, copy as a path, okay, and we're going to put it in here. We're going to name this path 2. Now we're going to put eval equals false, and we're going to just add this real quick, the name of the file. Read.csv. Control V. We're going to erase this part right here. And then we have to change all of those backslashes into forward slashes. Make sure it's selected, 7 occur. That seems right. Now we'll run that. And then we'll make another one called path 2 that we don't run. Wait, actually, we'll say include equals false. So the printed out version doesn't include it, but evaluate is default true. We'll put this one, knitter do not run this, but include equals true, so that they know to look up their file on your file location. Okay. All right. So it's a larger pathology data. And then let's just go ahead and give a link to it. Here is the pathology database. I have to go get it. Oh man. So I am always impressed by people. This nice guy. Oh, geez, like a. Oh, okay. Pathology. This could be it. It's the same date. Let's just open it up. Looks like it is. It's got what we need. This is where you get this file. We did not add the autism to it. I'll go ahead and share it. Copy the link. And then get out of the way. Then close it. I can open it back up if it doesn't work. Control V paste. Let's save it. Okay, so we already ran the path 2. Don't run this one. Right here, we're gonna open this file up. So we're gonna set the working directory. It only does it within the chunk. So path 2, it just takes that path and opens it. And then we're gonna name this file pathology DB. And I think the default is header true. Let's go ahead and look at what we got. Let's just do the column names of pathology DB. All right, great. So those are the names that we need to. Let's go ahead and put warning equals false. It's just letting you know only in that chunk it set the directory, but it went back to our working directory. Let's control S save. Let's just rerun it just because. See, put warning equals false, that won't show it. And those are the column names we have to change. We're going to be adding some information to the top 60. Let's go ahead and close these objects from our environment so we don't get confused. Let's open up the top 60 so we know what we're working with. We're also going to be using another file to merge these gene symbol IDs with the ensemble ID before we add it. So let's go ahead and do that as well. Make another, and then let's just write down how many dimensions this is. It is 385 by 7. Okay. Let's open the another file that we can add the ensemble IDs to the gene IDs of top 60 dataset. Okay, we're going to make another path 3. But we're going to go into this folder and get it. I already have it saved from another file right here. We're going to go ahead and copy this path. We're going to put it in our path 3. We're going to go ahead and, oops, it already copied the quotation marks. Let's go ahead and copy this, and make sure we select this box. We already have the / in and the / to replace all. 7 occurrences, sounds right. Now let's go ahead and put include equals false. And then let's copy this. Actually, let's cut it and put it here. This is going to be ensemble read.csv shift v. Okay. Let's do page table ensemble. Only the first 10 rows when we get there. For this, we're going to put eval equals false. And then we're going to put path 3, your file location. And we'll give you a link to it. It's in there. It's in the Google, they call it, the Google database. We're gonna have to set the working directory to path 3. So let's go ahead and do this first, and then we'll run this one too. Oops, let's put warning equals false. And we run it again. Okay. So this is what we want. We want to change. We want to merge by these gene names, which are gene IDs, by this ensemble ID, so that we can add it to our pathology database and have that gene ID. Let's go ahead and find this file first. We'll go back over here and we'll open up the Google. Sheets. It's most likely going to say ensemble. Ensemble ID. There's nothing in it. This is weird. Hold on. Why is there nothing in it? That's weird. Oh. All right. Well, let's see if there's another file that has it. Ensemble. I guess I didn't copy and paste it because ensemble. All right, let's just look real quick. All right, not seeing it in here. So let's just open that file again. Huh. No, that's not right. Where's that? Ensemble IDs. All right, we're just gonna open this and paste it then. Save file. Move the trash. We'll move this one to trash. Yeah. No, wait. Take out a trash. Okay. We're just gonna open up the file and select all. Go in the top corner, select all, Control C, and then go to Google. I mean, you had it in your file. Control V. It's a large file. It's like 20,000 rows, so it might take a while. It takes longer to copy and paste something than to upload it. Okay, good. So it did do what it's supposed to. Anyone with the link, copy. Then we'll go ahead and cursor there. Great. Let's go ahead and Control save this. Let's close out of this Google tab. Oh, wait, cancel. How do I save this? Okay, maybe it'll let me. I don't know. Look, Control S, save. Save it. And maybe there's a save button in here. Nope. It doesn't exactly run like Excel. It's Google Sheets. So we'll just wait. And let's go ahead now. And okay, so we have the gene IDs. So from here, we're going to merge the top 60 first, okay, with the ensemble IDs. Okay, let's merge top 60 with the ensemble IDs of ensemble data set. We already ran out of chunks. Let's make some more. All right. And now we're going to go back up. Let's close out this search tool bar, whatever it is. And then we'll go ahead and call this top 60 ensemble. We're going to go ahead and merge. We just want to merge the ensemble, but the first two columns, maybe it'll let us do that. And then also the top 60. And it's going to be by the gene in top 60, which is by.y equals, and the gene name in ensemble, by.x equals gene underscore name, by.y equals gene, capital Gene. And then it should just do it. Page table top 60 ensemble. Great. So that's what happened. We got the gene name, gene ID, because that's this ensemble one. It's not in the right order though when we want to merge it or when we want to combine it with the names of the pathology database. Let's just look at this in the console. Okay, so we want this one to be the first column. It's going to be named ensemble ID. And then this will be the second column. This will be the third column. The source, we will add it to the study summarized. Media type, this media type is RNA-seq, and it's from the, look, it's the LCL. Let's just go ahead and look. Colon cancer cells, actually. It's commercial colon cancer cells. Total RNA. So it's like the tumor cells, but it's colon cancer cells. So, and all right, that will be our media type. Study summarize. We're just going to summarize everything that this was and what our fold change is, how many samples. The gene ID will be the gene study ID. We have it at the top, or right there. This one right here. And we're also going to see what they did and how we, that there were duplicates of the 60. We had 23 genes, so unique. So we'll just type that out like we're typing a report, a summary. So we're going to go ahead because it's our data. That's how we made it, and that's how it's going to be. Okay. Let me get some water. All right, so let's do this. Let's arrange the columns. First in top 60 ensemble. Let's get rid of these ones. We don't need them anymore from our environment. These objects, let's save it also. Let's go to put top 60 ensemble in our environment and pathology DB in our environment. Merged with the ensemble for the ensemble ID. Okay, before combining with the pathology DB. Okay. So we will go ahead and control S. All right, let's top 60 E. We'll just call it top 60 E. We're gonna use top 60 ensemble. And that we'll just call it top 60 ensemble. That's what its name is. We're gonna use all the rows, comma, going to the column section of the bracket, we're going to get into where we want to arrange it. So we want the second ID as the first one, or the second column is the first one, the first one as the second one, the third and fourth are fine. So we'll just go 1, 1, and then 3, 4. Now we want the column names. Column names, top 60E are going to be these over here. Top gene, top all. So actually we'll just keep source the same. And we're just, yeah, so we'll go ahead and do that. We'll name the first 3 this. We're going to have to arrange, because this is whenever we add another column, it's going to be, so the source, let's name it study summarized. And then let's look at what we got. So we have the ensemble ID that checks gene cards ID, the FC pathology control, and then study summarized. We're going to actually add to this study summarized, but we're going to go ahead and add in the columns right now. So let's do that. Top 60E by, let's add the summary first. Study summarized. I believe we have to paste it. Paste. Paste top 60E. Okay, so hold on. The data separator equals top 60E. Okay, hold on. Let me see. I don't use this often, but concatenate vectors after converting to character concatenation happen in 2 ways. 2 basically different ways to determine whether collapsing being a string, not. Okay, separator equals, we'll just add a comma. Paste. What are we going to paste to it? Okay, so let's get rid of that one. Paste top 60E by study summarized. I think that's what it is. And then we add the studies. Okay, so this is colorectal cell line where 3 are wild type and 3 are the knock a gene that interacts with treatment to prevent mitotic cell division because AURKA is a promoter of mitosis cell replication. And there were a total of 6 samples, 3 of each. The fold change is the AURKA inhibited over the baseline control of the wild type colon cancer cells. And total it is total RNA used. Okay, now we're gonna put separator equals, and we'll just put a semicolon. Okay, and then let's see what the other. So let's see if this runs. We already have a summary there, so it's not like it's going to erase what's in the chunk. Let's see if it did what we wanted it to do. So we can just go to it right here. Top 60. Oh no, that's not the right one. It's actually top 60E. Yes, so it did paste it. If you hover over it, you could see it describes it. So that's our summary. Now we're going to go back and we are going to add the other IDs that we don't have. Top 60 by media type is colon cancer cells line. It's something like that. It says it. SW480. And then we're going to add another column. Oh, it's top 60. Oops. Okay. Because we already have a data set called. Don't want to add another column to it. It can interfere with things when you're running code again. If you have to recall it again. And then the other columns, let's see. So we have these 3 top gene pathology. We're going to add that one. This is colon cancer cells. AKA adenocarcinoma. That's what they described it on the site when you look up on Google SW480 colorectal colon cancer cells. Okay. But it did say colorectal, so the whole colon, including the rectum. And then we have to add the GSC study ID. Underscore study underscore ID. And it is GSE. Oh, it's actually in this little one right here. 302491. What are those? They're at. Okay. I can see if it presented. And we want them to be, hold on, that. In the console, look up column names of pathology DB. Oh, yeah, that's right. D. So we want them to be ensemble ID, gene cards ID, FC pathology control. We're going to have to add top gene pathology and media type in different orders. So we want to rearrange this top 60E2. We'll just name it that. Top 60E. We're going to keep all the rows, but rearrange it. We're going to keep 1 through 3 the same, but we're going to put top gene pathology, so 6, and then 5, 6, 5. Not order 5 will just be where it's at, and then study summarized, which will be 4, And then the 7 will be the same, but we still have to write it in like that. Now let's see. Column names top 60E2. And let's look at the column names in our source of pathology D3. They have to be the same so that we can row bind them to add them to our database. All right, looks like they are the same. All right, so now we're going to combine them. We can now add these genes to our pathology DB and upload to Google Sheets and use later. 11:12. Almost time to take out those chicken thighs. So I'm gonna go ahead and let's do that. Let's add it. Pathology DB2. We're going to bind pathology DB with top 60E2. And then we're gonna look at what we have. We'll write it out also. Okay, good. It did everything that we needed. We got the last one. You could see the top gene pathology. You could see this, the media type. Keep going. You can see the study summaries. Hover over it. The gene study ID. You can go earlier and see other studies. Oh, great. Let's write this out. Let's write this out to path 2. That was the one with the all pathologies. To path 2. And we can write it out here too. Path 2 in a separate chunk. Write.csv pathology DB2 pathology 5/4/2026 underscore CRC added dot CSV row dot names equal false. We'll put a warning here to make it not show. And then let's go ahead and write it out to this as well, to this folder. Great. Now you can get this pathology file here. All right. And then we don't really have time to go over Tableau, but I could show you real quick. My chicken thighs will burn the ovens. Hopefully they're not burning. And that's going to take a while. So I'll get to that later. Yeah. Or we could just take a break while I do that. And I'll just keep writing this. And so let's see. All right. Let's go ahead and upload this to Google Sheets. Finding this folder. All pathology. Current pathology database. And it should be this. Oh, it's this one right here. This one. There it is. All right, cool. We'll upload that. Import the data. Open up. Great. That's our data right there in Google Sheets. You can see it out of the colorectal cells. Anyone with the link, let's share this, copy. Then put the cursor here, Control V, paste, Control S, save. All right, cool. So we can go over the Tableau dashboard and see where this will fit in using all the data of this local project to link its own sheet in Tableau to use in the dashboard. And so let's go to that. Okay, I'm gonna go here. So when I go to hold on, I have it here. You can look Tableau Public. I signed in earlier. I don't know. I might make me sign in. Okay. It doesn't like to connect to the data. Open from Tableau Public. All right, so I'm gonna unshare this for right now. I'm gonna stop sharing, and then I'm just going to log in real quick. And I'll start sharing again. Entire screen, that one. And then we're here. Now I'm just going to go to it because I have so many files from overtime. And I have to find it. Here it is. This one. So in Tableau, I have to get all this data. All right. This is the workbook in Tableau on the desktop, public version, free version. What you do is, I'm gonna move this right here. I added a lot of the little folders that you see, all the data that they provided with all the information. You scroll through it, and these are each of those little data set files. We're in the dashboard right here. There's the key. You have to make a key. You can just go to the end. You can scroll to the very beginning. Notice they changed because there's just a couple more that don't fit all in here. I managed to squeeze all this on her. It's not necessarily pretty, but it's a good functionality. If you just want to see, here's the keys. All of these genes showed up in our key. I'm using the ensemble database of 50,000, and most of these have under 50,000, and all of it. Sometimes you'll find that there's not a connection between them. Mononucleosis, there won't be because that's all microRNA, which do not have any of the genes here. But you can click this gene right here. I just did. Sometimes it's slow. It's not in the pathology database because it came directly from the key. But if you want to see a gene that I have in the pathology database, you can. Let's see if the only thing is this is not actually alphabetized. So alphabetic, that would be great. Yeah, so let's do that. Let's do alphabetic. And then we're gonna go ahead and look. It doesn't really look like it made it alphabetic though, huh? All right, let's get rid of that one. You just press it once and wait. There's so many sheets here, it has to do everything. But it's basically connecting to all of these sheets to find that gene in these databases and where their fold changes within each pathology. We haven't added the colorectal cancer. We didn't add the autism. The Hodgkin's, I don't believe we added the Hodgkin's either with the large B cell. We didn't add the Hodgkin's with the large B cell either. Well, so many genes, but they're just not in alphabetical order. Maybe that would have been really nice, because then I could just easily look it up. And hold on. Data source order alphabetic. No, I wanted alphabetic. Why is it not alphabetic? A should be in the top. You shouldn't run into any A's at the end. They should be in order. And it's not. It's a little thing that's interferes with its functionality. But you can, like, if you, I don't have a search, it's not searching for it either. Don't use it as a filter. And it is a filter. So we'll go to our gene data here. Gene cards ID. You can look up there. It's unfortunate that they're so like to go through each one. You have to look and or you can just go to the file that it has. But this one I didn't add the gene to it, so it would have to be by ensemble ID. Which if I chose the ensemble ID, like with this one, it'll connect it with the gene ID here that's ensemble and the gene name. So it should, but this isn't a key filter. It's not made to be the filter, so it's not doing that. Those are some little nuances. Okay, this one is in gastric carcinoma. It's a top gene. Here's the ensemble ID. There's that gene. You can see the fold change. The uterine fibroid, I had all. That's because of the comparison of white to black females, and it was normal. If you wanted to see what the genes were, it was like the uterine fibroid, fold change for the black, for the white, and then at risk is basically the same. I believe it was the same uterus, but right next to the tumor. And the healthy are actually not at all. It's just a healthy person of that ethnicity. So you can look and see what the fold changes across all of them. So it's actually, when it says normal, it's like the healthy. So uterine fibroid gene expression changes over the normal healthy ones. So it's lowered in uterine fibroid. So it's inhibited, this gene. It's stimulated in the patient control, not stimulated interleukin 27. This one they took Epstein-Barr virus and they stimulated with interleukin 27 to see what happens. Nasopharyngeal carcinoma, it's also inhibited. It's inhibited in nasopharyngeal carcinoma and gastric carcinoma studies, separate studies. Normal fold change, so it's metastatic nasopharyngeal cancer compared to healthy. But non-metastatic is stimulated over healthy fold change. And the normal is also stimulated. So the normal and non-metastatic are stimulated. So it sounds like that's a good gene to help regulate and control health. In lymphoma, in uterine fibroid, in Epstein-Barr virus not stimulated with interleukin 27, it's all inhibited, as well as nasopharyngeal carcinoma, especially only the metastatic one. And then no information for the Hodgkin's that also have EBV and the HIV also. So nothing there, 0. In the gastric carcinoma, it's also inhibited. So MUCL3 is probably something that controls cancer, prevents cancer from taking over. That's just how you can use that data. And then if I go to where this is, hold on. I can go to Tableau might let me log in real quick. I know my chicken thighs are in there. I haven't logged in on the desktop in a while. Public desktop login. All right. So actually, I have this dashboard. It is saved on. Okay. So I already logged in. I don't want to have to log in again because then I have to ensure. Go get my chicken thighs too, though. Looking from Tableau Public, save to Tableau Public. Sure, let's do that. Maybe it'll let us view it too. It'll take us to Tableau Public, and then I can share it from there. You can actually download all of this too. Tableau will let you download all of this information as separate databases as a folder of each sheet. These are the sheets right here that you're putting. See the sheets right here? And if you go into each sheet, you can control what's there. And then this is all arranged on this tiny little dashboard that they give you. But this would be nice if this was alphabetical. And then if this also had the conversion to the gene name, I could reverse, I can merge it also with the ensemble key outside of here and add it again to get the gene ID. This would also be nice if it had the gene ID. Fibromyalgia. This one has both. This one only has the gene ID. Okay. Well, it does take a while because there's a lot of sheets. And I'll just share it with you real quick. And then we will see the work I do on this. I will just share publicly with you guys to know that you didn't miss anything. Okay. So I'll close that. And I'll close this. And we don't actually need this anymore, but I'm going to go ahead and knit it because we do want to publish that again. So I'll go ahead and knit that. I didn't leave a closing summary. I'll just knit it and then I'll just republish it and then I'll knit it again and republish it once it takes me there. Okay, so I'm going to go ahead and close this in this AURKA document to that Tableau document. I'm just republishing it now, but I'm going to add that link once it connects me to the server because I didn't want to log in and I need to get some chicken thighs out of the oven real quick. So close that. I'm going to leave this open. I'll leave this one open though, and then we'll go here and hide these toolbars. Go to the oh, look at that. There it is. Great. Awesome. So I'm going to go ahead and leave a little screenshot also and upload it. Wow, that feels plastic. Oh. Here we are. So I'll just go ahead and take a screenshot of this. You know what? I should scroll down a little out of this. I'm going to show you where. Okay, let's save this to the images. They were frozen actually, so they're not. I'm not too worried about it. Okay, save it. Yeah, it's also because I got other things going on too. I would like to save it. Hello. Yeah, it's taking forever. Anyhow, so this is how you download it. You download this. I'll download it right now and I'll show you. PowerPoint. Oh, Oh, I used to let you get the data. You might have to sign up for that. I used to let you get the Tableau workbook too. You can get the app. You can get it in the PDF, but I don't know. That's going to be probably crazy. You can share it. Okay, I'm going to share this. I'm going to copy the link. I'm going to go into this file. I'll just make this whole thing the link. And would have liked to save that picture, but it's just really, I don't know what's going on with this. Come on. It's not letting me save it. Oh, God. Okay, here we go. And then I'm going to save it to images. We're going to save this as Tableau, all lowercase. I'm going to close that. I'm going to go ahead and go here. Little screenshot. Dashboard. And we're going to images. And then it's Tableau. Oh, edit it like that. .png. All right, let's go to images and see how I spelled it. EAU.png. Images. Tableau. And maybe it's this way. Oh, I don't know. I always forget this one. Okay, so images, tab. That's the name of it. EA Tableau. Just images. Let's just look at it again. And I'm going to go ahead and close this one. Close this one. Insert in. Yeah, see, looked at it before. And it's taking a while because Tableau is on. I guess I can close Tableau. Take hour. We will be going to that though. Eventually. Okay, close it. Okay, so there's the brackets. There's the path to the image. I did right, so it should be showing it. Tableau.png. Okay. Let's just clear this one. The console and close it. Oh, it is there. So now I'm going to save this and then I'll knit it. And so now you have a link to it. We are going to add that one. I'm going to add this entire data set as a sheet to this Tableau dashboard next time. Today uploaded the genes that were top genes for all three types of all that of data extractions, CPM, and counts. We double checked for additional genes and only found the MCC gene present from the 10 genes. And we reviewed the autism data set to understand why we didn't add those top genes. That's 5810 accuracy. So, also would be nice to alphabetize the key in dashboard, as well as make sure each sheet has both types of IDs, like ensemble and the gene cards. Alright, cool. So I'm gonna go ahead and save that. I'll knit it and then I'll share it. You guys have a great rest of your day. I'm gonna go ahead and so okay. Here we are.